All right, so let's start this talk. So are you ready to talk about sustainability and green cloud-native engineering? Yeah. Oh, this is a little yes. I want to hear more. Are you ready? Great, awesome. All right, so first of all, thanks for the introduction. I'm going to just add a few words. So I come from the performance engineering world, like mentioned. So I've been testing, tuning, breaking, optimizing things, having fun at the end, to be honest. And 4 years ago, I joined Dynatrace, and I shifted naturally to this observing world, because when you're a performance engineer, you have to observe somehow. So performance is really in my heart. You will see in this presentation, I'm going to refer to different tactics that you do when you do performance engineering. So I'm trying to produce some content to help the community. So we are several persons in that area field. So it's called Perf Bites. So it used to be a podcast, and we moved it to a YouTube channel, so check it out. It's out there and just give you some performance engineering practice, methodology and help and whatever. And then Is It Observable is the YouTube channel that I started when I joined Dynatrace just to talk about observability in general. All right, so in this talk I thought, all right, how can we make it fun and change a bit how we can approach that topic? And I thought, okay, let me introduce this character called Captain Green. So Captain Green, in this story here, it comes from the future. You've seen a disaster. The way we are acting currently is we are going into a big danger. So he came back to our present, and he's trying to help us and say, guys, we need to avoid a catastrophe. And as every superhero movie or comic books, there's always a bad guy, and the bad guy is CloudNet. So if you recognize the logo, the logo of this of CloudNet, you may recognize the movie behind the scene. So CloudNet is basically we was offering in this area workload over the cloud. We were able to deploy, very convenient. I think it reminds you what we're doing at the moment. But the problem with CloudNet is that people were over-consuming, and we were eating more and more resources, and it impacted heavily our Earth. So Captain Green comes back here and try to help us. All right, so during this 30 minutes talk, we're going to talk about different angles. We're going to, of course, talk about the problem with resource allocations, the impact to the energy consumptions that we have in our workload. We're going to talk about, of course, unoptimized workload, and we're going to touch base moreover on what we should do to save energy. And for this, I'm going to introduce a few CNCF projects covered through the tax sustainability umbrella. There's Kepler, is one of them, KubeGreen, and behind the scene there's another open source project called Captain that I'm going to use specifically in the testing phase and CI/CD pipelines. All right, so first, let's share how the world and what happened, why Captain Green came back to our present, because there are a few things that made the world bad. So basically the machines took over, we had a war with them, but everything started in 2030, where data centers were consuming about 15%, a bit more than 50% of the global carbon footprint usage. As of now, if you just compare to what we have today, we are 3%. You may say 3% is nothing, but again, we have to react. And why we have to react? Simply for one simple reason is that first of all, everything in the industry relies on software. So we're building software for selling, for managing home, for to generate pictures of us with some, face recognitions. So software is here, and we have the options and the luxury to be able to run our workload everywhere in the world, pay per minutes, per hours. And sometimes we overconsume resources for nothing, for obvious reasons, because we are deploying things which is unoptimized. The other big thing, and I think this is contributing heavily to what's happening at the moment, is AI. There's an AI buzz. Everyone wants to have AI. Personally, I have an AI fatigue, to be honest. Everyone wants to have an AI implementations, and the problem with AI workload is that it's super heavy. It requires a lot of resources, heavily GPU chipsets, which is even more, requires even more power. So again, AI is cool, but if we just deploy AI without having, in fact, real value to our users, then what should we be doing in this? And currently the problem is that at the moment, the data center consumptions is at 3%, and it's growing every year by 1 to 2% per year. So if we are not acting currently, then in 2030, or 40, sorry, we will be at more than 50%. And 50%, to compare, the airline industry is about less than 20%. So it means that just our IT will consume more energy than just our airline company, which is crazy. So we have to react, and how we do that. So the first thing, when we have to optimize something, we have to measure. We have to understand where we are. If we don't know where we are, then there's no options to improve. So the first thing will be measuring. We need to measure and understand exactly how much we are consuming when we deploy our applications, containers, or whatever. So that's the first step. The second step is we may have unoptimized code running in our environments, so we need to optimize them. So I'm not going to touch base on that area, but by knowing which resource is consuming the most energy in your environments, then if you combine it with profiling, then you know exactly, okay, this is consuming a lot of CPU time, then I'm going to optimize that functions. Third thing is optimizing. So I'm going to touch base on this thing. We mentioned about it. vCluster mentioned about how we can reduce the number of clusters. So we're going to touch base on request and limits. So with Goldilocks, for example, on the vertical auto-scaling, you can also optimize things. So optimizing resource allocations is very important. And last is another important aspect is that in our environments, we have a lot of applications running for testing or for dev, and sometimes we don't even need them. We just need them for a few hours. So why do we leave those applications if we just need them for a few minutes? All right, so let's start with the first piece. So how can we measure? Very simple. There's a lot of projects out there. There's one project provided by rsync, which is quite interesting. But here I want to focus mainly on the project provided by CNCF, and Kepler is one of them. So Kepler, I don't know if you have heard about it. I guess you heard about it? No? Yeah? Nobody's using it? Yeah, he's using it. So Kepler is very simple. It's a daemon set that you deploy in a cluster. It relies on eBPF. So it will basically add eBPF probes in your nodes to measure the CPU cycles and the memory allocations. And of course, if you have GPU, it will also measure the GPU allocations required for your specific processes. And the great thing with Kepler is that it adds the Kubernetes metadata, so we know exactly, okay, this is coming from this namespace, this container, and we can also have the command behind the scenes. So it helps you to at least identify who is responsible within that pod that's consuming most of the resources. So the other important aspect is that Kepler, at the end of the day, is just a Prometheus exporter. So it's going to produce data. And again, people will say, yeah, but it's not estimated. It's just an estimation because this data center is green, this one isn't. We don't care. I mean, we are not here to look at the numbers. If we have a consistent number in our optimization process, and we rely on that number on and on and on, if it's just an estimation, it's fair enough for improving ourselves. So Kepler is an exporter, so you can either have Grafana dashboards available and use this to figure out which namespace is consuming the most, which process, and so on. But then, because it's an exporter, you can use the OpenTelemetry collector, any other solutions to feed a Datadog, Dynatrace, any observability solution of the market. So the idea is once we have that KPI, we know at least what is consuming and which container, which namespace we have to improve. And the idea behind the scene is that this KPI is key, and we should use it in our CI/CD pipeline. So we have CI/CD when we have a CI/CD pipeline, we build, we code, we build, we run some tests, so unit tests, functional tests, automation tests, load tests, and so on, and then we deploy. So my intention here is when you run the test, so I took the example of a load test, so you can run a load test, and then once the load test is finished, we want basically analyze. So we want to basically just automatically after the end of the load test, we want to measure the CPU, the response times, of course. We want to make sure that the application is still providing good response times, the request per second, so the throughput, and the energy consumption. So energy needs to be part of the actual performance measurements of our applications. So if it's basically a regression, we're consuming too much, we can block the deployment. So you may say, okay, how can I do this? Well, this is where Captain comes in the picture. So Captain is another CNCF project and provides an operator. And basically, Captain relies on one single constant that everyone here is the SLI, SLO, and SLA. So if you deploy the operator, you will basically define in Captain, in your Kubernetes environment, you will have a metric server exposing, helping you to extend the Kubernetes metric API. So you can define providers. So here you have, for example, Prometheus provider, Dynatrace provider. You can add a Datadog provider. Once you have the provider, then we're going to define an analyze template. So we will touch base on this. It's going to be the SLI at the end of the day. Then we're going to define analysis definitions. It's going to be your objective. And then once you have run your test, you say, okay, now I need to evaluate if I'm good or not. Good or bad, do you have any regression? So analyze will be the thing. So behind the scene, all those CRDs provided by the Captain metric operator. So let's jump into those settings. So here we have the SLI. I am defining an operator. So here a provider, sorry. So the provider is my provider, and we will touch base in 2 seconds with a small demo. I define my expression. So the expression depends, of course, on the provider. So if you have Prometheus, it's going to be from QL. If it's Datadog, it's going to be the metric expressions from Datadog. If it's Dynatrace, it's going to be And the great thing is here, I have the options to add variables. Because at the end, one SLI could cover all my namespaces, all my applications. So I don't have to rebuild the SLI. So here I have two variables. Then once I have this SLI defined, I will define my objective. So I'm defining, it relies on this SLI, and it needs to be greater than or lower than this value. And then we can define it if it's a key objective. So if it's a key objective, it could fail your actual evaluation. And then the weight. Weight means how many points you will get if it's a successful SLO. And last is I need to evaluate if the success of my release. So I will define the time frame, when, or how long, from the last 5 minutes, for example. And then here is where I'm precising the variables. So which namespace, in my case, of the query we mentioned before, and which pod we want to evaluate. So that's from a Captain perspective. So let's show this really briefly. In this, so I have prepared a small of a repo. Here is the QR code. You can find everything. So you have we will have Kepler. Kepler will push the data to Prometheus. We will have, of course, have Captain. And I will use the hip to shop in this example. We will have Istio. And in my case, I use Argo workflow to trigger this CI/CD pipeline. So if we jump back to the thing, let me just deploy this if I can. Oh, okay, shush, okay. Oh, that's going to be painful. Okay, and then let's bring this up. Boom. All right. No. Wait. That's not fun. Okay. If I can put this full screen. Yeah, it's going to maybe easier to change the actual display, I think. Okay. I'm trying to. It doesn't want to give me access to the. Okay, let's do it like this. Display.
If you did mirror it on,
Display up. Why I'm not able to change?
Is this the new Windows? That's because that's full screen.
Okay. Never mind. So let's try to do it that way. We're losing time. So here I am showing you a Captain provider. And if I am clicking on the other resources, I have a workflow. I've got a workflow that is here. And you can see that I have, come on. Okay. So I have a Argo workflow where I have different tasks. So I will first execute a load test, then run the analysis of the actual test that I executed. And then at the bottom here, I will print the results and store that into an artifact. At the end, the load test is just a task. So a task, what is it? What does it mean? It's up. It's basically in Captain you can trigger containers. So in my case, it's a job. So it's going to be just a load test, simple than this. And then at the end, I have the actual SLI. The actual no, it doesn't show it. Should. Okay. Okay. That's a mess. That's the god of the demo. It was quite painful with me today. Okay, so that's the SLO. And then we have the actual SLI, which I'm showing you, which is the PromQL I showed you before. So the PromQL here is basically I'm summing, it's just an example again. Here, what I'm trying to do is I'm measuring the namespace consumptions, and I'm trying to say, okay, this container cannot, I'm trying to figure out how much energy I'm consuming from that namespace, so the ratio of it. So here I'm targeting, it cannot be more than 30%. So this container is the checkout service for the user shop. So I'm calculating this, and then I get the feedback. So let's move on, because I lost a lot of time on this aspect. So now we touch base on the CI/CD and measuring validations from using Kepler metrics. The second aspect is optimize our resource allocations. And as you know, when you deploy in Kubernetes, I mean, we all know about it. When you deploy, you have different nodes available with different sizes, different hardware. And at the end, you have a total amount of resource allocatable, so CPU or memory. Every time you deploy, based on the requests, we will allocate the CPU, the memory, and then as a human being, sometimes we are intent to be very secure and ask for a lot of resources, even if we're not using it properly. So as a downside of this, we are allocating a lot of memory for nothing, blocking this, and we are not optimizing the usage of resources. So here in this example, you can see that we have almost allocated 95% of my cluster, and as a usage, I'm about 6%, which means I can do more, I could be more efficient. So the idea in this exercise is very simple. I'm going to compare what I have actually requested versus what I'm actually using. So I'm going to do calculate an efficiency of allocations. And then, as you may know, once you can always consume more than you have requested. So that's why I'm going to do the same thing exercise with the limits. So how much do I actually use versus where am I from the limit perspective? And so the exercise will be simple. It's, again, a load testing game. So I'm going to first measure a baseline to see where am I in terms of efficiency. Of course, taking in this angle the energy consumptions to see if we are improving in energy. And then I'm going to configure, so touch base one configuration, so one, for example, requests, run a simulations, do analysis again, and then if the parameter was successful, I keep it, and then I move on to the next parameter. So always touch base on one parameter, not 20 of them, because you don't know if it improved or not. And then, of course, I will always keep an eye on the response time, because at the end, if I am touching base the requests or the limits, I could have some throttling involved or having some issues. So I want to make sure that if I am improving energy, I still need to deliver proper services to my users. So I'm using here K6. K6 has different exporters available, so to Prometheus, to Dynatrace, to the other products. So which means I can keep an eye on the errors, the response times, and so on. Then to report those KPI, I will, of course, use Kepler. I need to have the hit per seconds actually on the container level. So I'm going to use Istio because Istio provides you this type of information. I'm going to use an OpenTree collector to basically collect those data and then send it to the right backend, so of your choice. And once you have the data, then you can calculate the efficiency of allocation in CPU, efficiency, memory allocations, and of course the resources, response times, and so on. So that's from a resource allocations. Now, let's move on to the last piece, which is how could we remove unuseful workload? To remove unuseful workload, to remind, we have different environments. We have the dev, we have a testing environment, we have production. So of course, I don't want to impact production. So here I'm going to be mainly targeting two environments, which is dev in one end and testing. So from a dev perspective, we has been presented by our colleagues from Loft. A lot of people is sometimes building a namespace for a developer or building different clusters. This is basically not efficient, and I think vCluster, for example, or there are other similar product out there on the market, you have the options to spin up a cluster, do your work, and then tear down or remove the virtual cluster, and also save the state. So which is basically you can respin it up to the next day and have the same values. So that's on the dev side. Now let's cover the testing side. And when it comes to testing, here is an example. Most of our testing practice, usually, if it's, you can run manual tests or automated tests or load tests, it happens that we have some traffic during a few hours of the day, and then during the nighttime, there's nothing. And we just keep that workload running for nothing, which doesn't make sense, because at the end, we're just blocking resources for nothing. We have some processes running and consuming CPU cycles for anything. We have memory allocated. So it doesn't make sense. So that's why Tax Sustainability introduced another great project called KubeGreen. And KubeGreen is basically designed to control, like a switch, to turn off the lights within our environment. So how does it work? Again, KubeGreen is an operator. So we will introduce a CRD. The CRD is called Sleep Info. And in Sleep Info, I would basically define, okay, so I'm targeting a specific namespace. And then I can define different settings. What are the week of the days will be impacted by these settings? And then when should I sleep that workload? And when should I wake up that workload? So you need to precisely tune up those timing, which is kind of difficult if you have to manage a lot of environments. And I will suggest how we can improve this. So the one important aspect is that you're not targeting a deployment or a stateful set or a daemon set. You're targeting a namespace. And it basically will reach out to all the workload within that namespace, and it will control the number of replica and turn down all the replica to 0 during the sleep time. And then turn on your replica properly when it's the wake up time. So let's do a small demo again, if I'm able to share my screen properly. And the intention here is to look at how we can basically optimize this configuration of KubeGreen. Because at the end, like I said, you need to figure out the sleep time and the wake time, which is kind of difficult. So for this here, I have a different workload. Here I have the Kepler, Dynatrace in my case, because I'm going to use a Dynatrace, but you can use low-key or other stuff in your case. KubeGreen, of course, ships the shop. And then I have in the default namespace, I have a collector to basically collect everything. And I will use Istio. Why? Because at the end, what I need is to figure out where do I have traffic and when I don't have traffic. So let me show you briefly. So I'm going to try it, if I'm able to do this. Okay. Okay. So here, what I'm showing you. Okay. What I'm showing you is weird. Okay, let's try to move it somewhere different. Let's reload this. What is going on? Okay, I don't know what's going on, but there's something weird. All right, so what I'm showing here is that to be able to calculate the last request when I should sleep or wake up my applications, I thought, okay, I'm going to use spans, traces, because traces give you the details of everything. But the problem with this is that if you know about OpenTelemetry and tracing in general, you have sampling in place, which means you won't have 100% of your assets, so you lose some details. You're not able to figure out exactly when you have the first incoming requests and the last incoming request. So in this particular example, what I'm doing is that Istio and Envoy specifically, is generating the logs, the access logs of your applications. So with logs, the advantage is there's no sampling. So I know exactly if I have one incoming request, I will have one incoming log in one log line within Envoy. So I can rely on logs to be able to detect those things. So what I'm doing here with this query, so you can use, for example, Loki to do the same thing, or Splunk or whatever. Here I'm querying the logs, and I can see here the raw logs of Envoy. And what I want to do here from that log is to get some details. So I will do some parsing, for example, so I can extract the response code, the request, and so on. But my intention here is to do some analytics. So I want to basically be able to say, okay, for this deployment in this namespace, I'm counting the number of entries in the logs. And then I want to have the first entry in the log of the day and the last entry of the log of the day. Once I have this, I can improve these statistics, where I'm going to say, okay, now that I have the first and last, I'm going to basically calculate the duration simply. And then I will make a filter to say, okay, I'm just interested in workload that is not running more than, let's say, less than 8 hours and more than 2 hours, 1 hour, to figure out which one I can technically shut down. Once I have this, then I can just create an automation. So you can do that from with Loki, for example. You can do this type of query, get the data, and then you can make decisions. So in my case, I didn't do a PR request, or I didn't do any similar fancy things. In my case, what I just simply did is I am sending a Slack message to the team involved, where I'm saying, okay, so for the last data, the last 24 hours, if I want to optimize this environment, I have the namespace hip to shop, and here you can start sleeping at 9 p.m. and you can wake up the next day at 8, for example. So here it's weird. So I received this information this morning, but the intention is to basically trigger this every day, so then you can tune up and optimize when you should basically turn off this namespace and when you should spin up this namespace. Again, there are no, there's currently the limitation of KubeGreen. It could be improved for sure, but I think it's a great initiative to be able to control and shut down a necessary workload in our environment. All right, so let's do a takeaway on this talk here. So if you want to improve the energy consumptions of your environments, we have to do several things. First, we have to measure, like mentioned. So using Kepler or other solutions that are available on the market is a must-have. So make sure that those solutions that you deploy in your environments, first of all, is having the right granularity. So be able to split by container, by namespace, by pod is a must-have. Then once you have that metric, like I said, use these metrics on your CI/CD pipeline to use as a main KPI to block deployments that may consume too much resources. So do it either manually, but it doesn't make sense, but try to use a quality gate, for example, that I showed you with Captain. Will allow you to automate the process and be more efficient. On the optimization part, I didn't talk about it, but we use profiling to optimize an unperformant code, but we can do the same approach with a code that is consuming a lot of CPU and by automatically a lot of resources. So we can optimize them by looking at the Kepler metric and then use profiling to just tune up this sequence of code. And last piece is kubegreen. So specifically in testing environments, so don't touch your production environment, of course, because it could be a disaster. But try to optimize your testing environments by dropping a workload that doesn't make sense to be there every day. So use, for example, the kubegreen project to have the options to sleep or wake up applications of your choice. All right, so a small teaser to the YouTube channel. So I try to produce content on all those different solutions on my YouTube channel. It's out there. I usually build a tutorial similar to the one you have seen here on the screen. So check it out there. I need feedback to improve the content. So if you like the content, say you like it. But if you don't like it, send me some comments, so then I can definitely improve the content. Thank you. If you have any questions, I am more than happy to answer to any of the questions.
Thanks so much. If you have any questions, you can raise your hand, and then Krista or somebody from the back can get to you. I have a thing right here. Krista right here. Or Ryan is going to get it.
Hi, thanks for the great talk. Really, really interesting. Can you talk about the Dynatrace shown in your talk? Is that open source, or does it have a free tier for other people to use it? Thank you.
Which one?
The Dynatrace you showed.
So I use Dynatrace because obviously I have Dynatrace due to the fact I'm working for Dynatrace. But again, you can, what I showed you with the query approach on logs, you can do that with Splunk, with Loki from Grafana has the same approach of querying your logs and parsing them. So you have different solutions available. When it comes to Dynatrace, of course, it's a commercial solution. So, but you have a free trial if you want to try it out for sure.
Just a question about when you're doing your performance testing and you find a regression in your energy consumption, what is the best practice for organizations to take? Like, will you literally throttle your CPU in order to stay within the boundaries there? I'm sure it goes company to company, project to project in terms of priorities, but do you find people in the industry actually reducing their performance because of the result of a performance degradation in energy consumption?
So it's a great question. So first, I think on the resource allocations and throttling and so on, the idea is that before you jump into IDing CI/CD pipeline and touching the request and limits, the idea is to do it before. So tune the actual sizing of your environments, and of course you won't introduce some heavy throttling on your application because at the end you have invested so much time to bring innovations, and then your innovation is a catastrophe because you've been throttled. So the idea is to find the right combination of request and limits that doesn't impact and introduce too much throttling, of course. And if you have a good balance between I have a good resource allocations and good response times, then we can go from there. From a CI/CD perspective, the idea is that if I know that I have the right settings at the moment, and I'm introducing, let's say, a new feature, and that feature is increasing the consumption of my pod from, let's say, 20%, then we should block it. And then say, okay, why do we consume so much resources now? And then if we know that, okay, this is this process from this container, then try to use profiling. So that this is, now you don't touch the resource anymore. You try to play, do we introduce anything bad with this code that we just deployed? Can we optimize it? If yes, we can save some energy.
Thank you so much.
I have a question for you too. So is there like a list or a forum where these techniques are listed, like how can you save energy, like, top 10 best ways to reduce waste and save energy?
It's a good question. I don't. I may say that tax sustainability is driving this initiative in general by driving recommendation and so on. So I would definitely recommend to look at what they're working on. There's also another group called I don't have the Green KCD Green Computing Foundation, KCF. Which is working mainly on every way of, first of all, measuring, because measuring the actual energy consumptions, there's plenty of different way of doing it, and they'll try to standardize the algorithm to do that. And they're also giving recommendation on how we should code in a more efficient way to reduce some energy. So both groups, you should check it out. They have lots of articles and lots of topics related to that subject, so I would recommend to go and check their content.
Well, thanks so much.